All right, this is the second part of 2.2. We talked yesterday and the day before, 2.1, about finding the vertex, how we find the vertex, negative b over 2a, then plugging back in to get y, graphing, all that stuff. We talked about given a standard equation, how to put it in vertex form. We talked about given a point and the vertex, how to put it in vertex or standard form. Okay, there's the video on that. That's the 2.1 first part. This is the second part. This is the 2.2 that we did yesterday. So I'm going to do these 3 examples with you. We'll talk through it. Any questions you have, I'll answer when we're done, and then we'll look at the homework. The last question on your quiz is going to look like this. It's going to say, okay, here's a bunch of problems. Tell me the end behavior. Tell me the x-intercepts, the zeros, the roots. That all means to do what? Find the zeros means to do what? Factor. Do not forget that. When you find the zeros, that means to factor. You're going to state the multiplicity. You're going to determine if it touches and turns or if it goes through the point. You're going to tell me the y-intercept, and then you're going to graph it. Everybody's quiz has a question that asks for all of this stuff. Okay, there's 3 questions on the quiz. Not each one is right or wrong, and then you get one wrong and you get a 66. No, there's a million different pieces to each question, so don't freak out. So if I look at number 10, the first thing I want you to do on every problem, guys, is make sure it is written with the exponents in descending order. The first thing you have to do. Is this equation written where the biggest exponent is first, then the second biggest, then all the way down? No. So how would you rewrite this? Negative 2x to the 4th. Then what? Plus 8x squared. If there's no sign in front, you assume it's positive. Then what? Minus 8. Okay, now we are in descending order of exponents. So now we can determine end behaviors and all that stuff. Look at the highest exponent. What is the highest exponent you see? 4. So my end behavior is 4 even or odd? Even. That means the arrows are going in the same direction or different? Same. So I know it's an even number, highest exponent, same direction. Look at the coefficient. Is that a positive or a negative number? Negative. That means both the arrows are going which way? Down. So it's falling on the left and falling on the right. First thing you need to determine, that's going to help you graph, guys. You need to know it's falling on both sides. Both sides going down. Mm-hmm.
Can you explain how, when we even or odd is from the exponent?
It's the highest exponent. If it's an even number, then both arrows are going in the same direction. If it's an odd number, then they're going in opposite directions. Good question. All right, so now I have to answer all these other things. But before you can answer anything else other than the y-intercept, you have to tell me what the zeros are. Then you can state the multiplicity and all that. So how do we find the zeros, guys? What does that mean? Factor. So over here to the side, I'm just going to say negative 2x to the 4th plus 8x squared minus 8 equals 0. Anything factor-wise is fair game. Okay, hang on one sec. Anything is fair game, though. GCF, difference of perfect squares, perfect square trinomial, factoring where a is 1, factoring where a is not 1, grouping, all that stuff that you guys have seen before. So the first thing you're going to do, like Mia just said, take out the GCF. What do all 3 of them have in common? Okay, so if I take out a negative 2, I'm left with what? X to the 4th minus 4x squared plus 4 equals 0. So I have negative 2. I can factor x to the 4th minus 4x squared plus 4. That's a trinomial. It's a perfect square. What times what gives you x to the 4th? X squared, x squared. Good. Good, Mia. What gives you positive 4 when you multiply, but a negative 4 when you add? Minus 2. Minus 2.
What about the negative 4?
When you FOIL that back out, that's what you would get x to the 4th minus 2x squared plus 4. Then you'd combine the 2 negative 2x squareds and get the negative 4.
Wait, would it be x is equal to plus or minus 2, and that would be...
Well, hang on one sec. Let's finish it. So set each piece equal to 0. Now solve it. The statement negative 2 equals 0. Is that true? No, so just cross it out. It doesn't count. If that had an x with it, then yes, you could solve it, but it doesn't. So now how would we solve this first equation right here? Add 2 to both sides. Good. So you have x squared equals 2. Then what? Take the square root. When I take the square root, what do I put? So it's plus or minus square root of 2.
And that would be like the multiplicity?
Hold on. So really, in reality, this is x equals root 2 and x equals negative root 2, right? That's what that plus or minus means? Okay, so I'm going to go over here and answer the other one. Well, it's the same thing, correct? So you have x squared equals 2. Take the square root, and I get x equals plus or minus root 2, right? Now, you can leave it as plus or minus. I suggest you actually write out x equals root 2 and x equals negative root 2, because what did Mia just say? There's multiplicity. Do you see how you have x equals the square root of 2 times, yes? Do you see how you have x equals negative root 2 how many times? 2 times. So to answer your question of stating the zeros, you guys would say,
Multiplicity.
well, first you tell me the zeros are at x equals the square root of 2 and x equals negative square root of 2. Can you write them all out? Absolutely. But the next question that you have to answer is there multiplicity, or state the multiplicity? So you would tell me there's multiplicity here, right? How many times? And then you would tell me what? Multiplicity here, 2 times. Then the next question is going to say, well, at those points on the graph, what does the graph do?
Bounces.
Correct. You can say bounces or touches and turns. I don't care. How do you know that it bounces? Because it's an even amount of multiplicity. Good. Very good.
When we write it
So it's when
down,
it's odd and it's so multiplicity, you don't bounce.
No, it would go through, but I'm not going to throw anything crazy at y'all.
when we're writing that down, can we just write M-U-L-T instead of multiplicity?
That's fine, Francisco. Oh my goodness.
Nice.
Okay, so when we've already answered end behaviors. You've already found the zeros. You've already stated the multiplicity. Already told me what the graph does. All right, one more thing you got to tell me before we graph it, and that would be the y-intercept. And we're going to write it as a point. What is the y-intercept? How do you find the y-intercept?
Plug it in.
Plug in 0 for
Everything.
x.
No X, basically.
So what is my y-intercept?
-8.
At 0, comma, -8. Just making sure. All right, now, let's go through and graph. Guys, I promise you I will set up your coordinate plane to where everything fits like it should. You know, you're not going to have to draw anything extra. You're not going to have to change the scale of the graph. I will make sure they all fit correctly. But you have to have your points at positive or negative root 2. Again, I'm not giving you any roots tomorrow to graph. The square root of 2 is in between 1 and 2.
Tomorrow?
Or Friday, whenever your quiz is. Friday. Yeah, my bad. I keep thinking tomorrow's Friday. I'm just hopeful. Where else do I have a point? At y equals -8. Good. Now, in order to graph, this is the part where you guys will get confused because you look at these points and you're like, oh gosh, how do I connect them? Here's a real easy way to get your mind wrapped around it. What did you guys tell me the end behavior is?
Fall left, fall right.
It falls on the left and it falls on the right. So it falls on the left, it falls on the right. Okay, so think about it. You guys told me what happens at negative root 2 and positive root 2 on my graph.
They bounce.
It bounces, it touches and turns. So from the left-hand side, go up in your mind, go up to root 2, and then what does it do?
Bounce.
It bounces, it goes down to -8, then it goes up to root 2, and it does what?
Bounce.
Bounces backwards. If you give yourself those little, arrows, it kind of gives you a direction of, okay, this is where I start and this is where I want to end up. So now I just go here. And it doesn't have to be perfect, but remember, our polynomial graphs have smooth curves. There's not sharp, shouldn't have sharp edges. Yes,
Like a
ma'am.
backwards W.
Or
Or
an
an
M is another way to say that. And it would be, oh, Mia. Yes, ma'am.
What if there wasn't a multiplicity?
It would go through. Well, I got some more examples. Huh?
How does it go through in that then?
Oh, that's.
Well, it's not going to end up to where it's like super awkward. Like that, it worked out like that. You'll see in a second. It's not going to, you'll always have multiplicity when it's even, because it's going to get back to where it started. All right, let's look at the second one. First thing, make sure, is this in descending order of highest exponents? Yes. Okay. So now you can tell me what the end behavior is. It's opposite direction. How do we know it's opposite? Good. My highest exponent is odd. We think odd. We think opposite. Is it positive 5 or negative 5? Positive. So think about a positive line, slopes up. Think about a cubic graph that's positive. What's happening on the left-hand side?
Rising.
On the left-hand side?
Oh,
It's
because
rising to the right,
It's-
falling to the left.
There you go. It's falling on the left-hand side,
Oh, I get
Yeah.
it.
rising on the right-hand side. Now you can tell me rising right, falling left, but just make sure you have the directions correct. Okay, so now we have that. Now we have to find the zeros and the multiplicity and blah, 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 right? How do we do that?
5x on the outside.
Okay, we're going to factor. Good. So I have 5x cubed minus 45x equals 0. Mia, what's the greatest common factor?
5x.
Perfect. So I'm left with x squared minus 9. Agreed?
Yes.
Now what?
We can factor x squared.
Minus 3x plus.
Okay, guys, look, that is the difference of perfect squares. X plus 3, x minus 3. If you don't see that, I'll show you in the next example how you can still get that same answer. But I have 5x times x plus 3, x minus 3, and that equals 0. Now to find my zeros, I set each piece
Equal to 0.
equal to 0.
Wait.
So here, x is 0. Here, x is negative 3. Here, x is positive 3. Well, look at your original equation. What was the highest exponent?
3.
So how many answers should I have?
3.
3. You're thinking turning points. Whatever the highest exponent is, that's how many answers you should. If it's x squared plus 9, you would move the 9 over and it would become negative. And then when you take the square root, you get an imaginary.
Isn't the y-intercept at 0?
Correct. Yes, it is.
It is?
Yes, but let's stay focused for 1 second. I appreciate your enthusiasm today. I really do. So now, state the multiplicity. Multiplicity means I have the same answer, the same root, more than once. So what would you tell me? You would tell me no multiplicity. So you're also answering another question. There's going to be a line that says, then tell me what the graph does. What does the graph do at all 3 of these points? It just goes through. And now once you get all that information, then it's really easy to picture what your graph is going to do. You also will have a line that says, what is the y-intercept? So if I look here at my equation, what is the y-intercept? It's at 0. So you'd say y-intercept at, and write it as a point, 0, 0. I want your x and y-intercepts written as points. If you have your axis of symmetry on your vertex, it should be x equals. If you have a minimum value on your vertex, you write y equals. I'm taking off points if you don't know that. So now if we graph, ladies and gents, where do I put points?
Negative 3, 0, negative.
Okay, so at negative 3, 0, positive 3. Perfect. Now remind yourself where we start and where we end. What is our end behavior?
Following the
So it's going down on the left and doing what on the right?
rising.
Perfect. Now in your mind, just kind of follow on the left-hand side. Where is your line you're going to, your graph? You're going to start on the left. You're going to go what at negative 3? You're going to go through it, or you're just going to bounce?
Through it.
You're going to go through it. Then you're going to come back down and do what at 0?
Go through.
Go through it. Then you're going to go back up and do what at 3?
Go through.
Go through it. Now, guys, you guys are going to ask me how high, how low. It doesn't matter. As long as you hit the x and y intercepts, I don't care. So if you come here and I go up through this point, just go up, come back down, go back.
Wait,
If-
really?
When you bounce though, isn't
That's not
That's not
bouncing.
bouncing.
I didn't bounce. I went right through the point.
it supposed to
If she bounced, it would have went.
I was thinking.
Some of you are going to say, well, wait, can I do this? you can go here. Like, you got to go through the point. Got to go through it. Got to go through it. You have to go through the point. You don't play connect the dots and just go up and then over and then up. You have to go through. Some of you will do this. You'll come here and you go all the way. I don't care. Go all the way back down, whatever. Just make sure that you go through each point and you have those bumps.
Okay, so I get it. So now it's bouncing.
Again, it doesn't matter if you go all the way up or really, just please don't do this. Don't go here and then go like,
Okay, yeah,
I was thinking.
that's not okay, because do I have any bounces?
No.
No, I didn't.
we're not bouncing.
We're not trying to bounce. We're going up and we need turning points. You guys don't know exactly where those turning points are up and down because you're not using your calculator, but you have to show me some sort of discernible. Look, I went through and then I came back down and then I go back up and that's fine. It can be really high, it can be little, but I gotta see that wave. Does that make sense?
Yes.
Okay. All right, let's look at this last one. First thing I look for is what? Before GCF.
Order.
Are they in the correct order?
Yes.
Yes. Okay. So I look now if I want to answer the question of end behavior. Is this odd or even?
Odd.
So it's opposite, right?
Yes.
Okay. Is that a positive 9 or negative 9?
Positive.
So it's going like this. What's happening on the left?
It's falling.
Falling left. Rising right. Correct?
Mm-hmm.
All right. Now, how do I find my zeros?
You equal it.
We're going to factor. Very good. So 18x squared minus x minus 2 equals 0. GCF.
You would do the
Is there a GCF? Hang on.
No.
No. Since I have 4 terms, then I'm going to group the first 2 and the second 2. Notice that I kept that negative sign with the x in the third term. What do I have in common between 9x cubed and 18x squared?
9x squared.
9x squared. What am I left with?
X plus.
Good. All right, what do I have in common? What can I take out of negative x minus 2? Negative 1, and I'm left with x plus 2 equals 0. So I rewrite my x plus 2 one time, because that's my new GCF, God bless you. And then what do I do with my leftovers?
You add them together in one.
I'm going to put them together in one parenthesis. Now, this is the difference of perfect squares. All right, I have my x plus 2. What is the difference of perfect squares here? 3x and 3x. Then what?
Plus 1.
Plus 1 minus 1. Okay, somebody last period said, wait a second, I didn't see that. That's okay. I can say x plus 2 equals 0. And then I can say 9x squared minus 1 equals 0, right? How would I solve 9x squared minus 1 equals 0? Move the 1 over. 9x squared equals 1. Divide by 9.
Wait.
X squared equals 1/9. And then what?
Just square root it.
Take the square root.
So that's. Can you have this? Yeah, you can.
What's the square root of 1?
Square root of 1 over 3.
What's the square root of 1? 1. What's the square root of 3? 9. And then what goes in the front? Plus or minus.
Wait, so does that mean 1 is just theoretically a perfect everything?
1 is just.
Good number.
Yep.
When you find the square root, some of them you put plus or minus, but you don't put the square root. Some of them
You always put, when you physically put the square, like if you take the square root of both, always.
always plus or minus square root.
Always. If you put the square root on yourself, like if it's x squared equals, then it's always plus or minus.
Wouldn't there be multiplicity that x is equal to?
Hang on 1 second, let's finish. Let's solve this. So I have x plus 2 equals 0. 3x plus 1 equals 0. 3x minus 1 equals 0. So here I have x equals negative 2. Here I have x equals negative 1/3. And here I have x equals positive 1/3, right? Which one? Over here? I advise you guys be careful. When you have plus or minus, I would write them out. X equals 1/3, x equals negative 1/3, because sometimes we miss that. But if I look at these 3 roots, are there any that are exactly the same?
No.
No. So is there multiplicity?
No.
There's no multiplicity.
You have to write that down.
It'll say state the multiplicity. If there isn't, you have to say. It won't hurt you, Francisco, I promise. I mean, it will if you don't write it.
True.
So what does that mean? If there's no multiplicity at any of those points, what does that mean about the graph? It goes through. There's going to be bumps, but it's going to go through. It just doesn't bounce. It's going to go through the x-axis. All right, and the last thing we need to know when we're graphing is what? The y-intercept. So y-intercept. Well, look at your equation. When I plug in 0 for all my x's, what's my y-intercept? Yep. So the point would be 0, -2.
Even when you factor, do you put like x is like 0, comma, negative? Like when you factor the answer.
Like to answer it, you could put x equals, if you
You
wanted,
just leave it
like x equals, and then do -2, comma, -1/3, comma, 1/3, like that.
Yeah.
Yeah, you can do that.
So use for like numbers, the one at the end is the y.
Whatever the constant is always your y-intercept. So guys, look, again, I'm going to change the graph here a little bit so you can see this a bit better. I'll make it fit perfectly fine on your whatever quiz version you have. So let's say this is 1. And this is 2. -1, -2. I'm just expanding it a little bit so you guys can see better, okay? So where do I put my points?
You do it
At -2. Where else?
-2 on the y-intercept,
Okay, -2 on the y. Where else?
and then -1/3.
-1/3, +1/3. So I'll say it's like here-ish. I'm just trying to space it out so you guys can see better. That's it. Now, what does my end behavior look like?
It rises to the right equals to the
Okay, so falling down here, rising over here. What happens, guys, at each one of these points? I'll do it in this color. What happens at each point? It's going to go through. So again, you're going to go through that point at -2 and then come back down to -1/3. So you're going to come here and you're going to go through it. Make sure you go through and just come back down. You have to physically go through. Show me it goes through, and then I don't care how high you go, doesn't matter. But then when you come back down, you see you have an actual point that you can go through. So it's like a guideline. But don't just go straight across. Actually show me that there is a bump there. Yes, ma'am.
Why is there 4 dots? Sorry, there's one.
We have 3 x-intercepts, and then we plotted the y-intercept.
Oh, right.
The last one, the y was 0, so,
Right.
and so it was also an x, so.
Wait. Oh, right. You're right. Yeah.
Okay,
There's 2 bumps. But there's 4 dots, so it's confusing.
right. Just make sure you hit your intercepts. A lot of times an x-intercept and the y-intercept are the same. When is it 0? All right.
It's just weird.
Hmm?
Yeah, without the Y-intercept.
Does that make sense?
Yeah, we got
You guys okay?
Yes.
All right.